Okay, today we are going to look at how to graph sine and cosine functions. And we're going to begin with our basic parent functions, and then we'll move into transformations. So we're going to begin with the function sine x. And to figure out the values for sine x as far as graphing goes, we want to remind ourselves what our unit circle looks like. And just a real basic, I don't want every single angle on my unit circle. I just want those main angles, the quadrantal angles. So I know that I have 0 over here on the right, pi over 2 on the top, pi on the left, 3 pi over 2 on the bottom, and then a full rotation is 2 pi. Now I can also fill in those coordinate points because this is a unit circle. I know my radius is 1. Now, normally for sine, we're thinking that sine is y over r. However, this is a unit circle, so r is 1. So if I want to start with sine of 0, well, at 0, those coordinates are 1, 0. And so in a unit circle, if sine is simply y, then my y value is 0. So there's my first point. So then let's move on. Then I'm going to do my next quadrantal, which is sine of pi over 2. Well, at pi over 2, those coordinates are 0, 1. So sine is the y value in the unit circle, y over r. So then y for that point is 1. So sine of pi over 2 equals 1. So these are giving us coordinate points. So then I'm going to have the next one is going to be at pi. So I'm going to do sine of pi. And at pi, that coordinate point is -1, 0. And so the y value there is 0. Then next we have sine of 3 pi over 2. At 3 pi over 2, that coordinate point is 0, -1. And so the y value is -1, which means the sine at 3 pi over 2 is -1. And then the last one is sine of 2 pi. Well, 2 pi is in the exact same position as 0, which means sine at that point should be exactly the same. So at 2 pi, our coordinates are also 1, 0. And so the y coordinate is 0. So sine of 2 pi equals 0. And then we know that we can continue doing rotations around the unit circle as many times as I want. But as I rotate around this unit circle, I'm going to keep getting the same y values over and over and over, which means that this graph is going to repeat itself. So then let's go ahead and put on here what we've got. So we started at sine 0. So we're going to put 0 right here. So at when theta is 0, then y is 0. Then at sine of pi over 2, so I want to kind of stretch this out so we can see. So I'm going to say that this is pi over 2, which means this will be pi. This will be 3 pi over 2, and this will be 2 pi. Okay, so at pi over 2, sine was +1. And again, I kind of want to stretch these out so we can see the shape well. So we're going to make this 1, this 2, and then we can also see that sine can be negative, so we want to make sure that we go in the negative direction as well. Okay, so then at 0, sine was 0, so there's our first point. At pi over 2, sine was 1, so there's our next point. At pi, sine was 0. At 3 pi over 2, sine was -1. And then at 2 pi, sine was 0 again. So if we connect these points, we can see that we're going to have this nice little rounded graph, and it kind of looks a little bit like a roller coaster. And then as we said, if we kept going around the circle, then once we get around to 2 pi, if I go for another rotation, well then my next sine value is going to be 1. Then it's going to be 0, because remember, y values. Then it will be -1, and then 0. And I can keep going over and over and over again, which means this graph is just going to keep repeating. So it's just going to look like a wave, just over and over and over. Now we know that we can go positively around the circle. We can also go negatively around the circle, and we're going to get the same values. So if I start at 0 and I go around backwards, then this is going to be negative pi over 2. So that would be right here, negative pi over 2. And that y value is -1. Then my next one, this would be negative pi. So negative pi. And that y value is 0. Then the next one, go around negative another quarter turn, and that gives us -3 pi over 2. And our y value there is +1. And then we finally get to a full negative rotation, so we're now at -2 pi, and that y value is 0. So we can see that for a negative rotation, I'm still getting those same values. And so I have that continual wave or roller coaster. So my trig functions will continue to repeat, and they can go forever and ever and ever, because we can do as many rotations around the unit circle as we want. So that's our basic trig function. Now, one full rotation goes from here to here. So that's what we call one period. So then we want to have over here that our period goes from 0 to 2 pi. And then if we keep going, then I'm just going to get those same values over and over. I start getting repeat answers. So our period is 2 pi, because I have to go all the way around the circle before I start getting that same pattern again. So that's our period. Now our domain, as we know, we can go positive or negative, rotate forever, as many times as we want, as long as we want. Therefore, our domain is going to be -infinity to +infinity. So I can keep going and going and going in either direction. Now my range is a little bit different. So look at our range. We can see that no matter which way we go or how many times we rotate, the lowest that graph is ever going to go is -1. The highest that graph is ever going to go is +1. Therefore, our range is -1 to +1, and both should have brackets because we do actually have points with those values. Now, what about symmetry? So if we think about symmetry, remember we can have x-axis symmetry, y-axis symmetry, or origin symmetry. So look at our graph without all of my little lines in here, and let's think about what would that look like if I tried to fold it on the x-axis, fold it on the y-axis, or for origin, if I tried to rotate that thing around the origin. So if I folded this on the x-axis, so that would be taking this half and folding it down here, and this half folding it up here. That's not going to match. So it's not x-axis symmetry. So how about y-axis symmetry? If I take this and fold it this way, then that's not going to match either, because this will flip over to here, no point there. This will flip over to here, no point there either. So therefore, how about origin symmetry? So take this thing and imagine that you stick your pencil right in the origin and you rotate it 180 degrees. It's going to look exactly the same. Therefore, this thing has origin symmetry. And then for even, odd, or neither, this is going to be an odd function. Okay, so that's our basic sine function. Next, we want to look at cosine. Now, we're going to look at transformations on these, but these are our basic functions, our parent functions. So now let's look at cosine x. Now, thinking about our unit circle, for cosine, we know that that is x over r. And since we're looking at a unit circle, we know r is 1. Therefore, cosine is simply going to be the x value. Well, let's just use this one up here that we already did. And actually, no, I lied. I'll redraw it. So this is going to be 1, 0, and that's at 0 pi. Then pi over 2 is 0, 1. Pi is -1, 0. And 3 pi over 2 is 0, -1. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, so let's take a look at our cosine value. So cosine is x, which means we are looking at only the x values. So I'm going to take 1, 0, -1, and 0. Those are going to be the cosine values, and then I go back around and I hit 2 pi, which is the same as 0. So I use the 1 again. So I can go all the way around the circle, which tells me that I'm going to go to 2 pi again. So I'm going to have 0 in the middle. Then I'm going to have pi over 2. Whoops. So pi over 2. Then I have pi, and 3 pi over 2, and 2 pi. And if I want to go backwards, negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. Okay, so let's take those values for cosine. So at 0, cosine is 1 because that's the x value. So, I should probably put my y value labels on here. So we'll make this 1, 2, this will be -1, and -2. Always make sure that you label both axes. Okay, so cosine at 0, cosine is 1. So there's my first point. Then at pi over 2, cosine is 0. Then at pi, cosine is -1. At 3 pi over 2, cosine is 0. And at 2 pi, cosine goes back to 1. And then at that point, I could keep rotating, but I'm going to get the same values over and over and over. Now, it looks like this is going to make a V, but it really doesn't. Our trig functions are always curved. So it's going to be this nice little curve. Then I'm going to curve through the bottom. Oops, I missed. And then up, and then curve back up here. So it's got a very similar shape to our sine function. However, the sine function started at 0. The cosine function starts at 1. However, notice my range is still the same. The lowest that graph goes is -1. The highest it goes is +1. Now if we go backwards, so negative pi over 2 is going to be here at 0. Then negative pi is going to be -1. Then we have negative 3 pi over 2 is 0. And then negative 2 pi is back to 1. So then if I go backwards, I still have that same basic behavior. I make sure it's nice and curved. And compare your sine and cosine functions. They have the exact same shape. Oh, hey, I went up too high on one of those points on the pink. Let's fix that real quick. That should be here. There we go. That looks better. Okay, so we have the same shape for the sine and cosine function. However, it appears as though one is a shifted version of the other. So if we take this one and we shift it this way a little bit, we would get the cosine function. Or if we take this one and we shift it this way a little bit, we're going to get the sine function. So they have almost the exact same graph, but just kind of shifted, but they are very similar. So we want to kind of keep that in mind. So let's fill in our characteristics for our cosine. So again, since we can keep going around the unit circle over and over and over as many times as we want, that means that our domain is going to be negative infinity to positive infinity. We can rotate negatively forever, or we can rotate positively forever. Our range, as we can see, again, only goes down to -1, and it only goes up to +1, and both of those need a bracket again. From our graph, we can tell that we're going to start getting the same values over and over again once we pass 2 pi. So from 0 to 2 pi, it has a unique behavior, but then that behavior is going to start repeating. So our period is 2 pi. Our symmetry. Now, if we look at how symmetrical this one is, it's a little bit easier to see. So if we look at this, if we folded it on the y-axis, then it's going to match. Every point over here on the positive side has a matching point over here on the negative side. Therefore, this one is going to have y-axis symmetry. And the cosine function is an even function. All right, those are our parent functions. So now we want to go through and we want to figure out how do we do our transformations for this. So let's go into our notes here. And there are several transformations that we're going to have, and they actually work very similar to other transformations we've had before for other functions. However, we call these things different names. Instead of having a vertical stretch or shrink, we say that we have an amplitude. Now, this is important. Pay attention. The amplitude is half the distance between the minimum and maximum of the graph. So if you let's take our parent function. So either one of these functions, the minimum was -1, the maximum was +1. So between the two, that's a distance of 2. However, the amplitude is half of that distance, so our amplitude is 1. So look at the total distance between the highest and the lowest point, and your amplitude is half of that. Now, what that's going to look like, the reason that our parent function has an amplitude of 1 is because our parent function just has this, which means there is an understood 1 in front of it. So our amplitude is 1. Or sometimes when there's no change in the amplitude, you'll see it written as none. There is no amplitude, which simply means there's not a change in the height of the graph. Okay, now your amplitude also, we want to make sure that we know the amplitude is the absolute value of whatever this number is in front of your sine or cosine. So your amplitude is never negative. Your amplitude is just a positive number. If there's a negative with this a, then that simply means that your graph is reflected over the x-axis, just like all graphs that we've ever done. So a negative means we reflect, so your graph is going to be upside down. Your amplitude, however, will be the positive version of that number. So what we want to do now is we want to take our basic sine function that we just graphed on the other page, and then we want to graph the transformed function. Now, the only difference between my parent function and my transformed function is this -2 in front. So we know the negative is going to reflect the graph, so it's going to be upside down. And then the 2 is going to be my amplitude, which means my overall height will be 4. So from the lowest point on the graph to the highest point on the graph is going to be 4, because remember, amplitude, this number, is half the distance between the lowest and the highest point. Okay, so it wants us to graph both the original parent function and the new transformed function. So I'm going to do my original in pink. So we said that it started for sine at 0, and I should probably label these. So I had 0, I had pi over 2, pi, 3 pi over 2, 2 pi, and notice that it says to sketch 2 full periods, so I cannot stop at 2 pi. I need to keep going. So beyond 2 pi, another quarter of a turn would be 5 pi over 2. Then I would have 6 pi over 2, which is really just 3 pi. Then I would have 7 pi over 2. And then I would have 8 pi over 2, which is 4 pi. Okay, so there are my two full periods. So for sine, for the first period, we said it started at 0. Let's see, we'll do this. 1, 2, 3, -1, -2, -3. All right, started at 0. Then at pi over 2, it was 1. Then at pi, it was 0. At 3 pi over 2, it was -1. And then at 2 pi, it went back to 0. So that's the end of one full period. Now I need to continue my pattern. So from 0, it's going to go back up to 1, then 0, then -1, and then 0. So that's going to be my basic sine function, but I have 2 full rotations. There we go. Okay, so that's the basic. Now we want to do the transformed function. So we know that it's going to be upside down. So instead of starting at 0 and going up, we're going to need to go down for that first point because it's reflected. Then instead of going up 1, I need to go down 2. So I'm still going to start at 0. However, instead of going up 1, it's going to go down 2. Then it's going to go back to 0, because if you take 0 and stretch it, it's still 0. Then instead of going to -1, it's going to go up to 2, then back to 0. Then instead of +1, it's going to be -2, back to 0. Then instead of -1, it's going to be +2, and then back to 0. And so we connect those, make them as smooth and curved as you can. And so there are 2 functions. So we can see that the new function, our blue function, is definitely taller. So it has a total distance of 4, and half of that total distance is 2, which is our amplitude. Okay, so I want you to go ahead and write in your notes that this original has an amplitude of 1, and our transformed one has an amplitude of 2, not -2, just 2. All right, so anytime that you put more than one graph on, or more than one function on a graph, you should really label them. So you want to label your original, y equals sine x, and you want to label the other one, y equals -2 sine x. Okay, so let's take a look at our next one. Alrighty. So then we're going to start with the basic cosine function. We know the basic cosine function. Think back to what we did just a few minutes ago. The first point for cosine was at 1, then it went to 0, then -1, then 0, and then +1. So going from 0 to 2 pi again. However, for our transformed function, we know that we're going to have a negative, which means it's going to be reflected upside down, and then an amplitude of 1/3. So our original has an amplitude of 1, and our new one has an amplitude of 1/3. Not -1/3, just 1/3. Now, most of us are tempted to, when we label our graph, to say, okay, 1, 2, 3, -1, -2, -3. However, because I know that this thing has an amplitude of 1/3, that means the entire height, the total height, is going to be 2/3. And I don't want to have to try to shrink my graph down in this tiny little space in here. So I'm actually going to think ahead, and I'm going to say, okay, instead of going 1, 2, 3, I'm actually going to make this 1 and this -1. And then when I shrink my graph down, I can use those nice, neat lines. So that means this would be 1/3, this would be 2/3. This would be -1/3, and this would be -2/3. So let's start with the basic cosine function. Make sure that you also label your horizontal axis. So we know that we're starting at 0. Then we have pi over 2, pi, 3 pi over 2, 2 pi. That's one full rotation. I need to go for another full rotation. So if I have pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, then that means this has to be 5 pi over 2. Then 6 pi over 2 is 3 pi, 7 pi over 2, and then 8 pi over 2, which is 4 pi. All right, so we have everything labeled. We're ready to go ahead and put those points on. So for the original cosine function, it started at 0, was 1. At pi over 2, 0. Pi is -1. 3 pi over 2 was 0. And then 2 pi was back up at 1. Then that's one full period. Now we need to do the second full period, which is going to go back to 0, back down to -1, back to 0, and then back up to +1. And so we're going to graph these with our nice smooth curves. Which is easier said than done sometimes. Okay, so there's the basic cosine function. Now it looks much bigger than the one we did before because based on the way we labeled our axis, we've kind of made it look stretched out. That was to make graphing the new function a little bit easier. So the first thing is we know that it's only going to be 1/3 of the height. So the highest it will go is +1/3. The lowest it will go is -1/3. And we also know based on the negative that it has been reflected over the x-axis. So instead of starting at +1, or in this case +1/3, it's actually going to start at -1/3. So it's going to start on the bottom at 1/3 of the height. It's still going to go to 0 because 0 shrunk is still 0. Then, instead of going down to -1, it's going to go up to 1/3, then back to 0, and then instead of going up to +1, it goes down to -1/3. So there's our first period of the cosine function. Now we want to do it again. So we already have our beginning point at 2 pi, then it goes back to 0, back to 1/3, back to 0, down to -1/3. And so we draw our second period for cosine. And there we go. Make sure you label. So our original was y equals cosine x. And then the new function is y equals -1/3 cosine x. Okay, so that's changing the amplitude. Like I said, always make sure that you label your axes clearly and then be very careful how high or low your function is going, and does it start at 0 as in sine, or does it start at 1 or whatever it's been changed to for cosine. Okay, next let's take a look at when they want us to do a change in period. So our basic function has a period of 2 pi. However, we can have basically this period change is the same thing as a horizontal stretch or shrink. Like I said, it's just called something different when we talk about trig functions. So your period is the distance between any two sets of repeating points of your sine or cosine function. So in our originals, we said that we could go to 2 pi and all of our values were unique. Then our pattern starts repeating after 2 pi. So where it starts repeating the pattern is where your period starts over. So the original had a period of 2 pi. These are going to have a different period based on what number is right here. So you're always looking at the number that is right in front of the x. If there's no number in front of the x, then that means your period is normal. It's just 2 pi. However, if you have any number in front of x, that b value is going to affect your period. And so we have a little formula here that's super important. We need to know this. You must have this memorized. So in order to get the period for your transformed function, you're going to take the original period, which is 2 pi, and you're going to divide it by whatever this b value is in front of the x. And that's going to give you the new period. Now, that's very important because the period of your transformed function is going to affect how we label the x-axis. So I'm not going to just automatically label this with 0, pi over 2, pi, 3 pi over 2, and 2 pi. Because if my period has changed, then it is much easier to label my axis based on my period than to take a standard labeled axis and try to squeeze or stretch that graph. It gets very difficult when you try to do it that way. So we're going to figure out what our period needs to be, and we're going to label our axis accordingly. So if we take a look at this function, it's a sine function, which means starting at 0, not 1. And we're going to sketch it when it has an amplitude of 2. That's great. That means it's going to go up to 2, down to negative 2. No big deal. But this 2 in front of the x tells me that my period is no longer 2 pi. So to get my period, I'm going to do 2 pi, because that's the normal period, divided by this 2 right here, and that's going to give me pi. 2 pi divided by 2 is pi. So my period is going to be pi, which means that when I label my points, so I always have 5 points on a single period for either sine or cosine. So instead of ending at 2 pi, I want to end at pi, because my period has been altered. Now, what do I label the other ones? Sometimes it's pretty easy. This one's not bad to see. But what you're going to do is we need to know, how are we counting? Well, we know this is always 0. No big deal. So when it's not quite as easy to see as this one, then to get your x-axis labels, you are going to take what you know your what your period should be, which is pi, and then you're going to divide it by 4. So it's always the period divided by 4. Our period for this problem is supposed to be pi, so that means pi divided by 4 is just pi over 4. So that means that is what we're counting our labels, or how we're going to label our x-axis. So this first one after 0 should be pi over 4. Then, actually, let me change this to black so my graph stands out a little better. Okay, so then, if that first one is pi over 4, the second one should be 2 pi over 4, which is pi over 2. Always simplify. Then the next one would be 3 pi over 4, which does not simplify. And then the last one would be 4 pi over 4, which, sure enough, is the pi that we said we should end at. So then we can sketch our graph now. We know what our labels should be. We're going to have those same 5 points, but instead of going up to 1 and down to negative 1, we're going to go up to 2 and down to negative 2. So then I start at 0 because this is sine. Then I go, oop, I haven't labeled my y-axis. So let's make this 1 and 2. and -1 and -2. So my parent function would go to +1. However, this has an amplitude of 2, which we should go ahead and label over here. My amplitude is 2. So that means it needs to go up to +2. Then back to 0, down to -2, back to 0. So that is one period of our sine function, and this one did not ask me to do a second period, so I am good to go. All right, so I have basically done a horizontal compression because the normal function would have gone out here to 2 pi. However, mine only goes to pi. So that's what we call a change in period. Then we've also done our amplitude change, and that's it. All right, so amplitude and period, and then we have our graph. Great. All right, let's look at another one using cosine. Now we see that this one is going to have an amplitude of 3. So amplitude is 3. It is not reflected, and we know cosine, the normal cosine, would go 1, 0, -1, 0, 1, and then have that nice little curve. Okay, however, ours is going to go 3 and -3. So next we need to figure out what our period should be. So for the period, we need to figure out what our b is. Remember, b is always the number in front of x. So this is b. Now, my normal period would be 2 pi. But I need to divide that by whatever b is, which is 1/2. Now, we don't really do fractions in fractions. So think, keep, change, flip, multiply by the reciprocal. That's really 2 pi times the reciprocal of 1/2, which is 2/1. That means my period is 4 pi. Great. Okay, so I have my amplitude, I have my period. Now I need to figure out how in the world do I need to label my x-axis. My y-axis is easy. I know I need to go up to 3, down to -3, so 1, 2, and 3. And -1, -2, and -3. Okay, now let's figure out how to label our x-axis. So for our x-axis labels. Well, if the period is now 4 pi, then it's obviously being stretched. So it's not going to be pi over 2, pi, 3 pi over 2, and 2 pi. It's going to be stretched out more. So the period for this graph should be 4 pi, and I need to divide that by 4 because I have 4 marks that I need to label. We know the beginning, the middle, just starts at 0, and then 4 pi divided by 4 is pi. So that means each one of these marks is going to be counting by pi. So I have 0 in the middle, then that means that this is pi, this is 2 pi, 3 pi, and 4 pi. So that's one period. If I needed to do 2 periods, then I would just extend this out and I'd say, okay, 5 pi, 6 pi, 7 pi, 8 pi. So just keep on counting. So I only need to do 1 full period though, so I am good with stopping at 4 pi. Now, I know that this is cosine, so remember, cosine is supposed to go 1, 0, -1, 0, and 1. But since our amplitude is 3, then that means it's actually going to start at 3, still goes back to 0, then it goes down to -3, back to 0, and then up to +3. So by changing the labels on our axis, we can really just memorize the pattern for sine and the pattern for cosine, and I just put those points in. I change my labels instead of trying to move, stretch, squish, whatever our graph. Much, much easier that way. All right, so that is changing our period. The next thing we need to look at is what we call a phase shift. And a phase shift is really basically the same thing as a horizontal shift. Now, if you think about all the other graphs we've ever done, a horizontal shift always comes from something that is either added or subtracted within the function. So within the parentheses or the radical or whatever symbol you have. So horizontal shift is inside, which means a phase shift is also inside. Now, one thing we need to be careful of is my phase shift is not simply pi. Something that they're going to throw at you that you need to be very careful of and be on the lookout for is if there is a number in front of the x, you must, absolutely must, factor that out before you determine what your phase shift is. So we know that we are going to be asked to tell what the amplitude is, the period, and our phase shift, which I'm just going to put as PS, phase shift. Okay, amplitude is easy. There is nothing in front of sine, which means it's an understood 1. So our amplitude is 1, or you could write none. You'll see it either way. Our period is going to be determined by the number in front of x, and that's 2. However, not 2 just because it appears here, but because that's what I have to factor out. So if I factor that out, I'm going to have y equals sine, and then I factor that 2 out of the parentheses, and that leaves me with x minus pi over 2. Because remember, when you factor something out, you're essentially dividing each one of these things by 2. So that means that we do have a b value of 2, which tells me that my period is going to be the normal period, which is 2 pi, divided by my b value, which is 2. So my period is simply pi. Okay, then from that I can figure out what my x-axis labels need to be. So let's go ahead and do that. Ooh. All right, so then if my period needs to be pi, and I have to break that up into 4 labels, then that means each label needs to be pi over 4. So these are my x-axis labels. All right, so I know right there in the middle I have 0. Then this is going to be pi over 4. Then the next one is going to be 2 pi over 4, which simplifies to pi over 2. Then 3 pi over 4. Then 4 pi over 4, which simplifies to just pi. And then this one says, well, it doesn't say to do 2, but I am going to go ahead and label more because since I do have a phase shift, I know that I'm going to have to shift one way or another. So we're going to go ahead and do some more labels because at the moment, I'm not sure which way and how much I'm going to have to shift. So if pi was 4 pi over 4, then I need 5 pi over 4. Then 6 pi over 4 simplifies to 3 pi over 2. Then 7 pi over 4. And then 8 pi over 4 is 2 pi. Okay, so I have lots of labels, probably more than I need, but that's okay. I'd rather have too many than not enough. Now, to figure out our phase shift, if you think back to horizontal shifts in all other graphs, we always said that the inside was opposite or inside lies. And that's the same here as well. So if this is going to be the opposite, then that minus pi over 2, instead of meaning it goes left, it's actually going to the right. So this is going to be right pi over 2. Now, don't make this harder than it has to be. We have our axis labeled. We know that every mark on my axis is going to be a point on our graph because we have labeled the axis that way. We've already taken into account the change in the period. So once you relabel your axis, you do not need to worry about the period anymore. You just need to figure out where that first point will be, and your first point is going to be right pi over 2. So that means positive. So positive pi over 2 is your first point on your sine function. Now, the normal sine function starts at 0, so this one is also going to start at 0, but this time that 0 is going to be at pi over 2. So pi over 2 is going to be 0, and my next point is at 3 pi over 4, and we know for sine it's supposed to start at 0 and then go up. So it's going to go up to positive 1 because it has an amplitude of 1. It's going to go back to 0, then it's going to go down to negative 1, and then back to 0. And then since they didn't say that I had to do more than one full rotation or more than one full period, I'm going to stop there. I have my 5 main points. I'm good to go. I'm going to connect those and be done. So remember, once we determine what the period needs to be and we relabel our axis based on that, you no longer worry about that anymore. You just figure out where that first point goes and do your pattern. Sine starts at 1, goes up, 0, down, 0. Cosine starts at 1, goes down to 0, negative 1, 0, back to 1. So if you can memorize that pattern, then these become much, much more simple. All right, so that is a phase shift or a horizontal shift. There's one more type of transformation that we haven't talked about yet, and that is a vertical shift. Now, this next function gives us a vertical shift. Now, let's talk about how we know. So we said for the phase shift, it always came from inside the parentheses. So a phase shift is always going to have parentheses. All right, then a vertical shift, no parentheses. So if you don't see parentheses, then that's a vertical shift, not a horizontal or phase shift. All right, so I have no parentheses here, which means this -2 is a vertical shift instead of a phase shift. Now, it is possible to have both, and so if so, you're going to look at whatever's inside the parentheses is your phase shift, whatever's behind the parentheses is your vertical shift. Now, this one is a cosine function, and our basic cosine function, remember, begins at 1, 0, -1, 0, back to positive 1. Now, our amplitude has changed, though. So we are asked to find the amplitude, the period, the phase shift, and the vertical shift. Now, vertical shift, the rules work just the way they do in every other function. Plus is up, minus is down. So our amplitude is easy. In front of the function, we have a 2, so our amplitude is 2. Our period, so period is determined by what is in front of x. And in front of x, I have an understood 1, which means my period has not changed. It's going to remain the same as our basic function, and the period of our basic function is 2 pi. Now, based on that period, that tells me that my labels, so my x-axis labels, are going to be the same as they were for my parent function. Because I'm going to take my period of 2 pi, I'm going to divide it into those 4 equal sections, and that gives me pi over 2. So my x-axis labels should be counting by pi over 2. So I'm going to have this first one is pi over 2. Then the next one would be 2 pi over 2, which is pi. Then 3 pi over 2. 4 pi over 2, which is 2 pi. And again, I'm going to do some more because I'm not totally sure which way I'm shifting, if I'm shifting. So I'm going to go ahead and do more just in case. Then, see, that was 4 pi over 2, so next we have 5 pi over 2, 6 pi over 2, which is, 3 pi, and then I'm out of marks. If I needed to go backwards, which sometimes we will have to depending on our phase shift, remember it would go negative pi over 2, and then negative pi, negative 3 pi over 2, and so forth. Okay, so we know that this thing is supposed to have an amplitude of 2, which means a total height of 4. So let's go ahead and put that in just for our reference. Total, height is 4. Okay, now phase shift. Since there is no parentheses here, that means that there is no phase shift. So you are simply going to write none. We are not scooting left or right at all. My vertical shift is this -2 behind the x. And so that is down 2. Now, if that's down 2, then that means the center of my graph is no longer going to be at 0. So all the other functions that I've done, if we look back, have been the center of our graph, the horizontal center was at 0. This is not going to be the case if I have a vertical shift. So instead of it being at 0, the horizontal center of my graph is now going to be at -2. So this is going to be my new quote-unquote x-axis. So we're still going to use that same basic pattern. Sine begins at 0, cosine begins at 1, and we follow the pattern from there. However, my new quote-unquote 0 is at -2. So if our amplitude is 2, then we know instead of the cosine beginning 1 above that horizontal center, it's going to start at 2 above that horizontal center. So it's going to start here. Then it's going to go down to the 0, which remember is our -2. Then it's going to go 2 below that, then back, and then 2 above that. So there is our cosine function. So notice it has that same shape as a cosine function, but it's just shifted down. So once you know what your vertical shift is, I want you to take that and I want you to go ahead and draw yourself your new acting x-axis. And then you're going to do your pattern based on that new line. Alrighty, so let's see. We have everything we were asked to find, and so we are good. We've got one more that we're going to look at. And this one's got a whole lot of stuff in it. So we have a change in amplitude. So we can tell right away that our amplitude is going to be 2. So amplitude is 2. So that means we have a total height of 4. This is a sine function, which means it would normally start at 0, go to 1, back to 0, down to -1, back to 0. So that's our normal sine behavior. Now, we do have some other things going on. So we're going to possibly have a new period. We can possibly have a phase shift and possibly have a vertical shift. So let's see what we have. Our period is only changed from 2 pi if there's a number in front of x. I have nothing here other than a 1. Therefore, my period is unchanged. It is still 2 pi. My phase shift. I do have a phase shift, and remember that it is opposite. So instead of being positive pi over 2, that means our graph is going to begin at negative pi over 2. So that's where your graph will begin, which tells me that I'm going to have to label some things on the left side of the y-axis this time, because my graph is supposed to begin on the negative side. Now, so this is going to be left pi over 2. And then I also have a vertical shift. And since that's positive, it's going to be up 1. All right, first thing I want to do is I'm going to draw my new quote-unquote x-axis. And if that's up 1, then that means it's going to be at +1. So I'm going to label these. Did I label these last ones? I didn't label my y-axis. I'm so bad. Make sure you do that. Okay, so label my y-axis. 1, 2, 3, -1, -2, -3. Okay, so this is going to be my new acting x-axis. Then let's figure out what our period labels need to be. So since our period is the normal 2 pi, that means our axis should be labeled normally, because my x-axis labels, we take the period, which did not change, we divide it by 4, and then that becomes pi over 2 simplified. So when I label my x-axis, I'm going to do pi over 2, which means this would have to be negative pi over 2. Then after pi over 2 is 2 pi over 2, which is pi. Then 3 pi over 2, and then 4 pi over 2, which is 2 pi. Again, if you needed to go more than one period, you just keep going. You would do 4 more labels after that. Okay, so we know, so we have taken care of the phase shift by labeling, or not phase shift, the period by labeling our axis. We know that our graph is going to be twice as tall, so instead of going up 1, it's going to go up 2 and down 2. We've taken care of this. The only thing that we really have left to worry about is making sure that we begin in the right place. So since it's left, oh, why do I have a 4 up there? Man, that should be 2. Pi over 2. So it's going to begin at pi over 2. Now, sine begins at 0, but remember, we have our new quote-unquote 0 or x-axis, which means our graph is starting here. Oh, nope. At negative pi over 2, and our quote-unquote 0. And then we're going up 2, then back to our 0, then down 2, and then back to our 0. So we have our sine function that has been shifted up 1, left pi over 2, and stretched by 2. Alrighty, so that's a lot in one. The big thing is take your time. Don't rush. Make sure that you determine what your period needs to be based on your B. And then once you know what your period is, figure out what those x-axis labels should be to make your job much, much easier. Alrighty, that is it, and I will see you guys